online teaching platform. We are still on how to find the derivative of a function from the first principles. Now we have a question here which is from the first principles, find the first derivative of the function y if y is equal to the square root of x. So the y prime here is the same as dy dx. So we have to find the derivative of the function y is equal to the square root of x. So first state my function is y is equal to square root of x, which implies that our f of x will be equal to the square root of x. Right. So we need to find our f of x plus h. So our f of x plus h simply means we are to plug in x plus h for x in the original function. So we are going to get square root of x plus h. So we have replaced the x. Whenever you see x in the original function, you plug in x plus h. All right. So let us continue. So continue by putting out the formula, which is dy dx is equal to the limit as h approaches 0, then f of x plus h minus the f of x, which is the original function, all divided by h, which is a small change in the input. Now the input is the x. So we need to just plug in the value. So we have our f of x plus h to be square root of x plus h. Then our f of x is the original function. So minus the original function, which is square root of x, all divided by h. Now you can see that the numerator of the fraction is made up of sets. So we need to rationalize the numerator of the fraction by multiplying through with the conjugate of the numerator. Since we have square root of x plus h minus square root of x, the conjugate of the expression becomes the square root of x plus h plus the sign minus changes to plus. So that is the only thing that we will be using. And you need to use it to multiply both the numerator and the denominator, which is the concept of equivalent fraction. So we are applying the concept of equivalent fraction over it. All right, so we are going to get the limit as h approaches 0. So we'll be getting square root of x plus 8 minus square root of x all divided by h. Now we multiply through by the conjugate. That's what we are going to do now. So we need to multiply through by the conjugate. So the conjugate comes square root of x plus h minus square root of, but here it's plus, so it's, the original one is plus minus, so this one becomes plus square root of x divided by the same thing. We are applying the concept of equivalent fraction here. So you could see that square root of x plus h plus square root of x dividing itself will still give us 1. So it doesn't change anything, or it doesn't add any value to what you already have. The value the value remains the same. So that's how you are supposed to go about it. Let us continue to simplify. So we'll be getting the limit as h approaches 0. So we multiply a numerator by a numerator. Anytime you are multiplying two fractions, so square root of x plus h minus square root of x, that is the numerator of the first fraction, multiply the numerator of the second fraction, which is the same thing, but just that the sign changes to plus. Square root of x plus h plus square root of x. Then close it nicely. Same thing will be done to the denominators. We are going to get h also multiplying square root of x plus h plus square root of x. Good. So you could see that when you look at the numerator, we can apply the concept of difference of two squares. Since the two expressions are the same, just that one is having a plus sign and the other one is having a minus sign. So it becomes the limit of square root of x plus h in bracket squared minus the square root of the second term, which is square root of x, that is all squared, then divided by, I'm still repeating everything we have as the denominator. So square root of x plus h in bracket plus square root of x, then close it nicely as h approaches 0. So our numerator becomes, since we have this one here, this square cancels the square root. Another one here also cancels this. So we'll be getting the limit as h approaches 0. Then we're getting x plus h minus x, all divided by h multiplying square root of x plus h plus square root of x. Alright, so we need to simplify. So since we have this one here, you consider this one minus this, we are getting 0. So we'll be left with the limit as h approaches 0. Then the numerator becomes h divided by h multiplying the square root of x plus h plus square root of x, all in one bracket. So we'll be getting, so I think you could say that the numerator has a term h, and the denominator also has h multiplying the two terms in the bracket. So we have to just cancel out. So we can now cancel this, the h. So this one, so this, sorry, so this h cancels this. We are left with the limit as h approaches 0. Then we have 1 as the numerator. Then in the bracket, we'll be left with square root of x plus h, then plus square root of x. Right. So you can now take the limit. You can now take the limit of what you have. So you'll be having 1 divided by square root of x plus 0, because you are replacing h with 0, plus square root of x. So you'll be getting 1 divided by square root of x plus square root of x. And this will give us 1 divided by 2 square root of x. These are like sets. These are like sets. So when you add them, we have 1 here. Here too we have 1. So it becomes 2 square root of x. Alright. So you can continue to simplify. But you can equally give your answer in this form. You can continue to rationalize it. So that will be 1 divided by 2 square root of x times square root of x divided by square root of x. So at the end, we get square root of x divided by 2x. Alright. So this becomes the derivative of the given function from the first principle. Bye.